There we go.
So the live stream has begun. Very good. Hello, everyone. Welcome to the fourth stage of 3D construction printing competition. And we are moving into final posters and final 3D models and then presentations. And to start this very important stage of our competition here in the Baltics, we have a very special guest, Dr. Fabian from PERI, and he's head of 3D construction printing. We will hear, or this evening, depending on which country you are. I think for participants in China, it's almost early morning. So we will hear introduction presentation to large scale concrete printing, because in our competition, we have only chair-sized models and propositions. So with a look towards future, with a round of applause, we can welcome Dr. Fabian. Thank you for joining us today. Virtual applause.
Thank you for having me. A pleasure. Then I'll dive right into the presentation. I'll share my screen with everybody. And you let me know once you see it again. Now, unfortunately, I can't see anybody else, but I assume you're here.
Yeah, see your screen perfectly.
Perfect. All right. Let me basically introduce myself again real quick. So I'm Fabian. I'm responsible for all the 3D printing stuff here at PERI. I'm actually a physicist by profession. Worked for the big, larger corporations with Siemens and Daimler in the past, and joined PERI about 7 years ago. PERI, we're the largest manufacturer of formwork and scaffolding solutions worldwide, with our headquarters in southern Germany, but we have presences all over the world. Well, we're a 100% family-owned company. And hence, we don't have any banks or investors in the background, which push us to maximize profit the next quarter. I mean, don't get me wrong, we're here to make money, but still we have a long-term view on things, and hence can develop technologies very in a sustainable fashion long-term. Hence, we have, let's call us a think tank in-house who tackle disruptive technologies, as we call them, and not necessarily just 3D printing, but also, for example, autonomous construction of rebar, building in slums, etc. And 3D printing has been on our minds, and we've been actively pushing it for quite a while now. But why? Why are we doing 3D printing? So again, for a formwork company, it's obviously, well, we've been shaping concrete for thousands of years with the help of a formwork. And now with 3D construction printing, we can shape concrete without the use of a formwork. That could put us in a lot of trouble. If this works on a grander scale, we would be selling less formwork, and obviously not good for business. And we are of the opinion, if somebody's going to disrupt our business, it better be ourselves. Then we all still have jobs in 50 years and the company is still around. So that's a very PERI-centric worldview, of course. And as you know, and I'm not going to spend too much time on this next slide here, because I assume all of you guys who have been already thinking about 3D construction printing, this is nothing new, but we all have these major issues worldwide in terms of housing shortage and labor shortage and material scarcity, and actually also a rather low productivity in construction, which is highlighted with this chart, which is a study from McKinsey that's now more than a decade old, but I think it's probably still very valid also today. That shows in the blue line the low productivity in construction compared to the manufacturing industry. And now all of these trends that I've just mentioned, they obviously don't go very well together. So we have there quite a problem on our hands. And we feel that 3D construction printing can be one answer to these problems. Definitely not the only one. It's not the holy grail that's all going to solve all of our problems, but it can be one very important answer. This is also what we as a company are aiming for, together with our technology partner, Cobot, who is a company in Denmark, where we as PERI are what's called the seed shareholder. We are working very closely with them on the machinery side. But as you will be seeing in this presentation, the machine is one thing. but there is a lot more that goes into making 3D printing successful. So what we aim for is definitely faster completion times at less cost. We're not quite there yet, I'm going to tell you that already, but I will go in more detail on where we are. Freedom of design. I've taken a preliminary look at some of the designs of the different groups, and I love the designs there. But again, I'm a physicist, so I'm definitely the wrong person to ask if a design is pretty. To me, the freedom of design is a lot about functionality. So I'm too pragmatic for the design aspect, but it adds function to a structure, and how can we utilize that? We want to address the shortage of skilled labor, and we want to actually address that from two sides, as I'll showcase on the next slide. Error reduction, definitely a point on the list. Increase in work safety. An automated site is usually a clean site, and clean sites are usually safe sites. And last, but definitely not least, it's about the sustainability issue. And in my presentation, I will go through all of these points and try to highlight where we are, and also definitely where we are sometimes not with the technology at this point. Regarding labor shortage, again, we want to tackle it from two sides. So yes, we want to make sure that we have less labor on the site. Definitely a very, very important point to us. But on the other hand, we also want to attract young talent again to the construction sites across the globe. Again, physicist, not a construction dude by training, and I love working in this industry. It's a lot of fun. Well, we see that I think across the globe, people don't really want to enter this industry anymore. The picture that you see in this slide on the top left-hand corner, there will come a day that somebody will sue me for using that picture because I stole it online, but very purposefully have not shown the source, because actually a construction company in Germany was looking for apprentices in the masonry for a masonry job with this picture, with somebody, you know, bending down, very unhealthy for your back. I don't think that they were very successful in hiring people with this picture. On the other hand, if you work with a big robot, you can use the other picture, a young person with a laptop operating big machine. Let me tell you, it's a lot easier finding motivated people to work in this type of environment. And I think that's what we need to do in the future. It's still construction, you still get dirty, but you also still create houses or offices, structures that people live in and work in, and that can be a very rewarding job from my point of view. And we've actually seen that happening with our clients that we have today. We have a company in Germany where there's two brothers, and one of them never wanted to have to do anything with construction. He wanted to go into IT, and then he did, and then he saw the 3D printer, and now he's all on board for getting active in the 3D construction printing industry. So labor shortage, tackling that from two sides. This slide, I don't think it's too relevant for all of you guys. It's just I always have it in my slide set in terms of what's the basic of the extrusion type of 3D printing. I mean, there's obviously other types of additive manufacturing and construction, but we are very focused on the extrusion. But what I still want to highlight a couple of things, and that's why I will go through the slide anyway. We all know that we can't print too fast, otherwise our material will slump. If we stack it layer by layer, we can't go too slow either, otherwise the material will not bond, and we will always have these cold joints everywhere. What we need is this kind of optimum sweet spot. And this sweet spot we usually achieve with the compromise of three things. It's obviously what type of material are we printing with. There's various materials out there, some that are very high tech. They start setting after like 3 seconds. There's some with gravel in it, some that are mortar, some with fibers, etc., etc. So definitely the material is one important point. The other is, well, how fast are we printing? What is our layer time, as we call it, and how fast is the machine running around? And the last is, well, what are we printing? Are we printing a chair or a flower pot, where we put on the next layer after whatever, 3 seconds or maybe 20? Or are we printing a whole building where we have potentially more than 20 minutes of layer time? That always plays a big role. And from the beginning on, we actually liked large scale also for, in the end, printing smaller parts. And why is that? If we print large scale in a bigger footprint, we can use, let's say, more normal materials that don't necessarily have to be high tech, lots of additives, and be setting extremely quickly. Because all of you that have been printing before with concrete, I'm sure you've had some clogged hoses or some clogged mixer pumps, and that's usually not a lot of fun. And if you have a bigger footprint and have materials with a longer open time, you can avoid that very, very easily. So we've always liked big, even if in the end you print several smaller parts, the bigger footprint makes life a lot easier. So as mentioned earlier, we've been doing this for quite a while, but the future has already started for us. We are not in a pure research state anymore. I mean, obviously there's still a lot of work going on, but we're also very active on the market, and we we have clients that are working with the machine continuously, and all of these pictures that you see here are actually from a client in a precast plant in southern Germany, company called Rebar. And I like their ideas and their designs, hence I've put them here. And that can be from logos to little benches to let's say furniture for gardening and landscaping, but it can also be manholes for infrastructure applications, or it can be parapets that can be installed on site. So bottom line, I don't really have a strong emotion on if you print in a prefabricated environment, or if you print on a site a whole building, or if you print building elements close to a site and then bring them to the site. The whole discussion of is modular construction preferred to in situ construction doesn't have anything to do with 3D printing from my point of view. For decades and decades, we've been using modular construction as well as on-site construction, and both building methods have their place in the construction industry. And 3D printing, the fun part of it is the printer first and foremost is a big tool. What you do with that tool is a completely different storyline. Nonetheless, if you go into such a technology, unfortunately, we can't do it all. I mean, we are a growing team and more people working on it, but we're still not huge. And hence, we think it makes a lot of sense to focus. And if you work with a kind of startup mindset, you really need to focus on one thing and do that well, and not try to do too many different things at once. Given this, we really liked the applications in housing. And why? Well, again, huge problems when it comes to housing. Second, if you take a look at where the largest construction volume is and the largest market, that's actually in single family housing, at least if you take a look at it from a global perspective. So nice market there. And then also it's a good starting point in terms of, well, you might not want to start with a skyscraper or with a bridge, but maybe single family housing is actually a good place to start with a technology like this. And then the last very, very important point is, well, if you go on a single family housing construction site today that is being built in situ, the automation level is 0. So we can really add value with bringing automation on a construction site. Now we wanted to embark on that journey to start printing a house in Germany. And we didn't really have the goal of it in the end being the first one in Germany. We're rather happy it was, but that wasn't the goal. If we wanted to print the first house in Germany, we would have done that in whatever 2018. We have a big parking spot where our headquarters is, so we would have cleared a little bit of room, printed a little garden hut, popped a couple of bottles of champagne and did some marketing, and then 2 weeks later tear it down again. But yeah, that doesn't really fit to our family-owned business. We want to do real world and real world projects and real world buildings where the overall construction process makes sense. And I think that's always very important to keep into consideration, to not only look at the printing process itself, but at the overall process. So tiles, paint, plaster, electrical, roof, connections to the foundations, all these little things you have to figure out to make the overall process sensible. So we wanted to do a building that makes sense from the overall construction process, and we wanted to have it real in a sense that people are going to be actually living in them. So not just a weird demo house, but a completely fully permitted normal building. And this is the journey that we embarked upon. When we started that process, one of the first questions we asked ourselves, of course, is now we have this beautiful freedom of design. How do we utilize it? Are we going to do a rectangle? Well, obviously not. But again, the design is one question, but I'm not the right person to ask about design, but I can do maths. So if I take a 200 square meter rectangle and we turn that into a circle of 200 square meter, again, the same area, the circumference of said structure will have reduced by almost a quarter. So regarding sustainability, amazing, but also good for the wallet. So less material printed, really nice. So we should start building a lot of cylinder houses, but then we might have a problem. So how, well, it's nice if you can hang a picture on the wall and if your IKEA furniture still fits into the room. And it's also, I really wasn't keen on having the guy kill me that has to put in the tiles into this. So then we decided, okay, let's go a slightly different route. And the architect that we were working with, Waldemar Korte at the time, came up with this design, which we really liked, which has plenty of straight walls, but it still shows the curvature that 3D printing can bring. Obviously, it doesn't take the design, let's say, to the fullest extent, but again, it also still makes sense from a construction standpoint. The next question we had to ask ourselves was, okay, now, what are the walls that we're building actually looking like? Are we going to do a solid wall and then we're going to insulate it from the outside and then we plaster it? Or are we going to do kind of this zigzag line in a hollow wall? Or what are we going to do? We in the end decided to do a hollow wall structure with an exposed 3D printed facade. Why? Definitely one very important reason was that we did want to show off. We did want to showcase to the world that it is a 3D printed house and people from afar should see, okay, look, it's special, something is, and hence definitely we didn't want to plaster the building from the outside in the end. But there are also more pragmatic reasons. The other one is plastering is actually quite expensive. So if you don't need plastering, brilliant, you're saving construction cost. Second, if you create a void for your insulation, you can use very efficient insulating process with using blow-in insulation. And also this blow-in insulation does follow your round shapes very easily compared to, let's say, these insulation boards that all of you have seen before. So hollow wall construction. Now that we knew we were going to create this hollow wall, the next thing was, okay, we want to get it permitted. And well, Germany isn't really famous for efficient bureaucracy or easy permitting process. I think the exact opposite is true. Then we needed to talk to the permitting offices and figure out a way to get it permitted. And the only way to do it is a lot of testing to prove that the structures that we are printing are safe and sound for the inhabitants of the structures. Obviously, that's of the utmost importance. So what we did is we printed a lot, and we printed not just small specimen, but that we've tested, of course, for compression and E-modulus and tensile strength, etc. But we really printed also whole wall elements, 2.40 meters by 2.40 meters, and we tested those. We broke facade elements square meter wise, 4-point bending test, horizontally and vertically, freezing and thawing. So a lot of testing went into this. To really prove that the overall process is stable and efficient. We also had to do some nonsense tests that I've simply not been able to convince the authorities that we not need them. That is actually showcased in this picture here in the top right-hand corner, where you have to take this little metal ball, which weighs about like 1 kilogram, and you have to use a pendulum, and then you drop the pendulum and the ball swings and hits your concrete. 11.5 centimeters of concrete and a 1 kilogram ball of metal. obviously that was going to hold. I've always told the people from the officials that, look, we are test printing a lot. Why don't you come by? I'm going to give you a sledgehammer and you can break down a couple of walls and then we can get rid of this very weird test. But unfortunately, they didn't really want to follow my advice, but we had to go through that very bureaucratic process. But we were successful. And then we did have to figure out all these other details. Connections to the roof, how do you waterproof it, how do you do the foundation, how do you do a lintel for a big terrace window, etc., etc. We had to rethink the overall construction process, but you also can. So we've always asked ourselves, how can we use 3D printing to make the lives of all the other trades that come into such a building easier? How can we save time and money across the overall building process? I'm not 100% sure that we found the best solutions to all of these problems. Actually, I'm very sure that we haven't. We have found a solution to each and every one of these challenges. But obviously, we're always open for discussions, because in particularly these building details have to be localized. They look very different, even obviously from whatever Switzerland to Denmark. But then if you go over to the US, it's a completely different ball game as well. So these details, the printing itself might be the same all over the globe, but the building details, the construction process is very different. And you can have the best printer in the world. If your overall construction process doesn't make sense, you're not gonna be successful. And then we were finally able to go out on the site and set up the Bot2 printer from Cobot there. That is a modular machine that comes in various different sizes, so you can always configure it to be the perfect size for your project or your construction site. Takes about 1.5 to 2 days to set it up in this particular configuration. Then you slice your model like you do it with every other 3D printer with polymer or metal. You put up your material silo, and then the machine does its job. We really like to work hand in hand with the machine. So we are not fully automated, and I don't really think it makes a whole lot of sense to be fully automated, because the human is also a brilliant machine that can do a lot of things. And then the printer, again, does its job layer by layer, and we put in all these little building details. And I'm going to pause the video here for a second. Very often I get the question, okay, why did we put this enclosure around the structure? And I think there's another angle here coming up. Actually not. But I think it becomes very clear that this is not really any weather protection, because there's a lot of open sky here. The reason that we did this was for non-disclosure reasons. We didn't want any Facebook or Instagram pictures before we did a press conference. Given this, we've enclosed the construction site to a height of about 4 meters, so that at least for the first story, we have peace and quietness, which actually wasn't true. I was very surprised how many people are trespassing on construction sites. And this little roof thing that you see here isn't really a roof. It's mostly needed to stiffen the tent structure around here. So again, you don't need it. Cost-wise, it wouldn't make any sense if you would need it. The projects that we've done in 2021 were all done without this weather protection enclosure. And this is what the final product looks like. Again, we're obviously very proud of the result. It's located in Beckum in North Rhine-Westphalia in Western Germany. It's still open for visits until August, and in August, the final owner of the building is going to move in. It's a lady called Lisa Hahnhus. It was clear from the beginning on that it's going to be her house. She was also involved in designing the floor plans. So very, very happy with that. I think the facade speaks for itself in terms of consistency that we were able to produce also under different weather conditions. If you look very, very closely, you will see a couple of vertical lines, in particular in this left-hand side picture. And this is actually where we combined in situ 3D printing with prefabricated 3D printing. So the parapet was printed as a prefabricated part, put on the site later on, because from the construction process point, we would have, the machine would have been sitting idly for quite a while before we could finally print the parapet, and it made much more sense to remove the machine from the site and then simply install the parapets later on as 3D printed parts. In this project, obviously design did play a major role. I mean, with the overhang, the loggia, little facade elements here, the overall shape of the building, that tilted column that was obviously on purposely that it was tilted. So that was also the goal in this building. We really did want to push the envelope a little bit in terms of design and what we can do here. And we did learn a lot. I mean, it wasn't the first time we printed, but the first time I think anybody ever did it on this scale, fully permitted with all the construction included for the interior as well. And if you do something for the very first time, that's metaphorically speaking, if you get on the bike the very first time, you tend to crash a lot, and actually probably mostly you're crashing and not riding a whole lot. And then you need to practice and practice and practice until you actually finally start riding the bike and not just crashing anymore. So here in the ground floor, it took us about 28 print days to print the whole ground floor. That is all in exterior and all interior walls. Way too long. 28 days is way too long for this type of construction. We had quite a nightmare with material logistics during that time. But the top floor was actually printed in just 8 days. So we just during this one project, we came from 28 days to 8 days, which highlights the learning curve here that we went through. And this is then what the interior looks like. So for example, a brilliant idea from the architect was to say, why don't we actually print the fireplace? So, okay, sure, let's print the fireplace. Why don't we print the handrail for the staircase? Yeah, sure, let's do that. We did not print the stairs themselves. That was cast in situ conventionally. Could we have printed it? Probably yes. From our point of view, it simply didn't make any sense to do so. It was easier to do it conventionally. And then this is the upstairs bathroom where we printed the support structure for the bathtub, of course, the handrail for the loggia, actually also the separation wall for your walk-in shower was 3D printed. And we printed openings for all electrical installations. So nobody had to drill any holes or cut any slots. All the electrical installation was done when we were done printing. So again, making the electrical a lot easier. We printed the stop and formwork for the foundation and for the slab, which actually conventionally could very well have been a PERI product. So we've basically already substituted parts of our current product portfolio, which was the aim after all. So really thinking about that overall construction process. Again, the facade, I think we at least are very happy with the print result. Again, wind, weather, we actually had a hailstorm sometime there in between. It did get a coat of paint in the end, but no plastering. And we very purposefully chose that very articulated, layered structure. Later on, I also have a couple of pictures in the slide that it can look differently if you want to. That's not really a technological issue. It's simply a matter of what type of design you're looking for. Then basically at the same time, almost in parallel, we did a second project located in southern Germany in a tiny village, right next to the church tower, next to the village square. So with this project, we had a completely different approach. It obviously wasn't about design. It's this very conventional southern German designs, rectangular box. Here we wanted to challenge us with two things, and we like challenges, at least for now. So that challenge was, number one, try to do it as fast as we possibly can. So really try to make good on the promise of saving time. And second, print in winter. So we printed here up to -5 degrees. We printed in snowfall. -5 was really kind of the limit. That was really challenging. And you can tell if you again look closely, you will see every now and then a layer that doesn't look all that pretty. That was the first couple of layers on the days where it was freezing temperatures. It took us a little while to get the process running stably. But you know, it is what it is. We also, this building is not going to be plastered. We now could have said, oh, the facade doesn't look so pretty, let's hide it. But we like to show what we can and what we can't do. We like to show the limits as well, very openly with our cards on the table. And I'd say you can print with -5 degrees. Don't necessarily have to do it again anytime soon, but everything 3 degrees and more is perfectly fine. And here, this is a multifamily home, 5 apartments. The ground floor area is 160 square meters, which is actually about twice of the ground floor area of the previous building that I had shown. Here, the print time for 1 story was just 7 days. So coming from 28 to 8 to doubling the ground floor area and still reducing the time. So very proud of that result. And that just highlights, I mean, again, this is kind of the second, maybe even the 1.5 time we've ever done it. So let's say we do it another 5 or 20 times, we are very sure this can be done in maybe 3 days per story. And then it's really a whole lot of fun. And also here again, this is every interior and exterior wall, non-load bearing as well as load bearing. Potentially in the future, we will replace a couple of the non-load bearing walls with dry walls, if it makes sense. We actually don't quite know. Also here, actually the tenants have moved in June last year. So 4 of the 5 apartments have people living in them, again, fully permitted real world buildings. We still have 1 apartment that's open for visitors that we can showcase. In the interior, it looks rather conventionally. Here from the beginning on, it was clear that the designer also wanted to plaster a lot of the interior walls. Actually, recently I had a visitor in this building who walked into it and then said, well, you know, looks like a house. And then I said, well, thank you very much. That was the goal. Very happy with that. We still kept a couple of design elements where you can see the 3D printed structures. Again, kind of this little gimmick here, instead of a painting, to have this little 3D printed element above the bed. So very happy in the end with the result. And then again, we are a globally operating company. I also have a team that's located in Houston and Texas, solely dedicated to 3D printing. And now we've done winter, so brilliant. So what about summer? So again, we like challenges. So how about, you know, we go to Arizona in June? It sounds like a brilliant idea to print something in June in the desert. With 50 degrees maximum temperature. And then we did that. I actually still feel slightly bad because at that time there was still the traveling to the United States was still very difficult because of the pandemic. So I was actually sitting very comfortably in a air-conditioned office in Germany while a couple of my American colleagues were out there on a bloody hot construction site in the middle of the desert. But we got it done. It's actually going to be inaugurated in just a week, where the people are going to move in. It's a building with Habitat for Humanity, so it goes to a family in need. I really need to update the pictures in my presentation because these are by now already a couple of months old. The building is finished, looks really nice. Again, completely different layout with the roof structure made of timber. In the US, they have a concept called a building inspector, something that I've never heard of in Europe. So the overall construction process, the permitting process, everything was very different. And the blistering heat in the desert was definitely very tough. Again, no tent, right? I think you've seen that there was no enclosure whatsoever. So very tough weather conditions. Again, might not necessarily want to do that again this year, but feasible. And of course, this just showcases to us that the technology is feasible in all these different conditions. Yes, we will have to improve on the process to make it more stable and more efficient, but it definitely can be done. We continued that journey also with another challenge. So obviously there is a lot of places where you're not going to have a level ground, but you might have a slope. So can we also print on a slope? And then there was an architect, Mr. Baldauf, who lives at the Lake Constance, and he wanted to do a building extension. So there is an existing building on the slope with 2 stories, and we wanted to print a 3rd story on top of that. And we did. Again, I don't really have high-end pictures yet. These are just taken from my cell phone. But you can see kind of the existing structure below here, and on top is what we've printed. You can maybe see the different heights in the Z columns. So definitely feasible to do this on a slope. Another one in the books, and we're going to highlight some pictures of the publish some pictures of the finished structure fairly soon on our LinkedIn and Instagram. And the journey continued even after that, where we did a building, an office building for Strabag, one of the largest contractors in Europe, which they came to us, wanted to do this very tiny 1-story building, rectangular design, and then we rather did a much more fancy design, and successfully printed it as well. And again, you can see that there is no enclosure around the structure. Also here, the print is done. We actually got very lucky. We got out of Austria just before they had another lockdown there. And we are gonna publish pictures of the final building soon. I really love that scene. I have to go back a little. This is one of my favorites. This is the construction site of the future, right? 2 of my colleagues just standing around doing nothing. That's what I always want to see. This particular project was actually printed with Holcim material, and the buildings in Germany were printed with Heidelberg material. Which is very important to us, that we are material agnostic, as we call it. So we are not trying to say, look, you have to use our proprietary mix and we ship that across the globe, which obviously wouldn't make any sense from a sustainability standpoint. But we feel material has to be local, 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 and we need to be able to print this with basically whatever. And we then help our clients and partners to find suitable mixes and to print with those in the end. You can find all of these videos also, by the way, on YouTube if you wanna see them in some higher end quality. Yeah, then a couple of pictures. Something that I also really like about this construction method without formwork, if you want to do some manual things to the structure, when the material is kind of in the process of drying, it's not hardened yet, but it's also not quite fluid anymore. So you can actually mold it in a way. So this is actually a place where they put in later a drywall, and they wanted to have the smooth connection, but they still wanted to keep a lot of the 3D printing facade as well. Hence, you can just manually, at the end of the day, smoothen up this wall, and you're done. That is very convenient, of course. Another fun project from our client Röser that I brought because I love the idea. They printed this little, they called it a tiny house. I still call it a garden hut. You name it, whatever you want. And here they moved the lorry, the flatbed truck, directly into the printer. Then with the foundation plate, and then they printed this little tiny house on top, waited for an hour, and then moved it out again. And the printing of this whole structure was done in just 4 hours. So and again, it's these guys haven't been printing for that long, and really, really nice results. So love the idea. I'm gonna maybe highlight that again. So here you can see the electrical outlets, you can see the insulation. In this case, the insulation is a volcanic stone, so 100% mineral and sustainable and recyclable material. We don't really care what you use as an insulation. It could be whatever. Always you have to take a look at the building physics. Rebar, important topic. So far, I've not really taken the word rebar into my mouth in this presentation. So we've been printing a lot without any type of reinforcement. You might have seen a couple of what we call wall binders, these little anchors, big staples. But those aren't really rebar. They're used to anchor the facade back to the rest of the building, because we don't want to connect the facade with concrete, because then we have thermal bridges, but we want to use these little anchors. For a 2-story building, also actually for a 4 or 5-story building, in most regions across the globe, these types of structures are not built out of reinforced concrete, but they're built out of bricks or maybe timber. So you don't really need the rebar. These are what we call compression-only structures. You only need rebar in certain instances. For example, if you have a tilted column, or if you are in an earthquake zone, you might need a tiny little bit of rebar here and there in a certain section. And if we do need that, then we print a lost formwork, we put in the rebar, then we continue to print the rest of the column, we put in the rest of the rebar, then we have the so-called overlap of the rebar, we cast it out conventionally, and then we are golden. Obviously, there is a lot of research going on in how can we integrate rebar directly into our 3D printed structures. So far, there's not really an economic way of doing that. But we and a lot of others are looking into it. But again, you don't start with skyscrapers or bridges. So it's perfectly fine for single family houses or also multifamily, that it's a big enough market where you don't really need the rebar. As promised, a couple of pictures on different surfaces. There you can have flaps on the Bot2 printer, or that's what we call them, these little whatever spatulas or trowels that basically are attached to the printhead, and then they can smoothen the wall while printing. It's not a fair-faced concrete wall, but still a lot smoother than the other. You can also go in the other extreme. You can do, let's say, kind of this woven structure. And you can also grind it down. And again, this was done just one day after printing. So if you wait until your structure is completely cured, it's going to be extremely difficult to grind down and very hard and dirty work. But if you do it the very next day, it's actually smooth sailing, and you can create these fair-faced surfaced walls as well. Good. I want to take just a couple of slides on the Cobot Bot2 while I'm at it. So again, the machine is modular, 2.5 meters in length. You can print with mortars or concretes or whatever. Again, very important to us to be material agnostic. The nozzle here can be basically any shape and size, and it turns with the print in order to create these smooth walls. And these numbers are actually by now also a little bit of outdated. I mean, you can do only 3 cm in width, but you can also do 50 cm in width if you want to. So to be really large scale in your prints. And we also don't really care if it's 1 cm or 4 cm in height. Again, that goes back to what I was saying in the very beginning of the presentation, to find this compromise between material, print speed, design, and there you can also adjust the width and the height of your layers. So to conclude a little bit, we here at PERI believe that this technology will change the way we build. We're probably just scratching the surface in terms of will it be housing or infrastructure, or where exactly will we be using this technology. It's still a young technology, though, of course it is. So we've not quite proven everything, and we still need to learn a lot. But we're also not in the research mode anymore, and we think we need to learn together. I hope that it came across that we are very open and about what we can and what we can't do with the technology, and we feel we just need people that have fun working on this and believe in the same vision as we, and then tackle this technology from there. We as PERI, we are actually, I've said now quite often that we have printed things, and that's perfectly true. We did. It was us and our people who've done it. But we're not really a contractor. Remember, we're the largest manufacturer of formwork and scaffolding. So we see ourselves as somebody to provide technology to the contractors or prefab plants across the globe. And that's also our vision. We don't want to become a contractor. I think it's going to be necessary in the next year or two to continue learning together with our clients. And at the same time, we are actively selling and renting this technology out to our clients. We want to help and train them and to make sure that the technology grows. And we are here to support, to share in this circle, but also in other instances, to share what we've learned and to help and to progress the technology as a whole. And we really think it's just time to take advantage of this technology and put it into practical applications. Thank you very much for your attention. And now I'd be very happy to answer all the questions that you have. I hope that I can answer them.
Applause to your presentation. It was really great, and thanks for having the time and energy to go through all the topics. We already have 2 or 3 questions here I have written down, and if anyone has more, you can either write them in a chat or raise your hand, and then we will give you ability to ask them in person. The first one came about the smoothing. Do you see any protection gains in weather durability, like freezing and thawing cycles? Does it add to that? Do you see a risk that water gets in the crevices and damages the surface in long term?
So we were worried about these very articulated layer structures in the beginning for exactly that reason, and also potentially for whatever moss growing on them. But they are we've coated the surface to make it hydrophobic, and we did freezing and thawing test with the material. We actually did twice the number of cycles that was required to be on the safe side, and we see that it was very good from the freezing and thawing performance. Hence, with the size of these layers, as they're rather tall, I don't really see an issue of water freezing and then cracking them. Hence, I also don't see that the smoothing of the walls would add to that. I see it more of as a really aesthetic question.
It actually could be interesting also acoustically, knowing that how the sound gets reflected. I think there could be some benefit in urban environments there.
Agreed.
Yeah. Maris, you will have the next question. I will just read one more which was sent in. We have noticed your hand. Otherwise, the second question is about angled walls. Have you done them already? I suppose it's the rebar thing that it needs to be reinforced in some way, but maybe you have a comment there. Have you tried some angles and what were the feedback?
So with the extrusion type printing, angles are difficult, period, because you have, I mean, normally with FDM printing, then you need support. So you need to print support structures, and to print support structures for a whole house is a little difficult.
A lot, yeah.
And concrete is bloody heavy. So no, it's everything below 10 degrees of overhang is definitely doable. 20 degrees potentially, depending on, again, material, print speed, layer time, etc. Everything above that, you will need a material that is highly accelerated, normally then directly in the printhead. I mean, there's beautiful work out there by Baumit or X3 who are doing that, who are accelerating the material in the printhead and create this very, very artistic structures, beautiful. So can be done with 3D printing in general, not necessarily with our approach that we follow. Again, to us, it's not quite about, let's say, the chairs or the art pieces, but for us, it's really about the construction. And there, you don't need the angles all that often. No.
Okay, Maris, yeah, thank you for the answers. And Maris, the next question, and after that, we will read one from Rebar.
Okay, thank you, Fabian, for presentation. I think it really showcased very well how far PERI has gone. I have, I think, several, but I will try to be short. I was wondering about the buildings you did in Germany. So when you do it according to some kind of code, you need to calculate it. And you mentioned like masonry structure. So did you do these buildings according to like it's called unreinforced masonry code where you did all those tests, or they were like specially designed tests for the printing?
So we used, that's a big question, and I'm going to try to be precise or concise in my answer. So we used masonry as well as concrete codes, and then we've tried to prove that the structures we've printed are basically equivalent to them, right? So for example, the facade element is taken out of a masonry code, the load-bearing concrete, 3D printed concrete walls and that actually, maybe I didn't really highlight that. There are 3D printed load-bearing walls in these buildings. Not all of the loads, some are on conventional concrete, but some load is on the 3D printed structure, which is a huge step forward. And there we used the concrete codes, and the tests were very standard in mostly, but we did always incorporate slight variations to pay tribute to the layer structure. So where the conventional concrete code says, look, you have to test a specimen that you cast and you're done, we had to at least test 3 specimens in all the different directions. But in general, it was developed, this testing procedure, together with the Technical University in Munich. And in general, it's very, very standard according to those codes.
Okay. And then how do you see those? Will those codes become like a more standard and like available for everybody? Because I think it is some kind of a limitation for this industry if everybody needs to like develop their own testing method. Because we are thinking, for example, doing the first house in Latvia, for example. I know that we will. There is so much legislation that I actually don't want to start even to think about it. Yeah, and I would like to just take some this EN standard from some Western European country and adapt it in Latvia, and then don't have to think. Do you think it will become like in a few years, or we need to wait a little bit more?
Here I have to talk a little bit longer because this is a very important topic. So 3 answers to your question. Number one, I think in all, at least in the countries that we've been active in with 3D printing, and it's more than 10 by now, there is always a way, a defined process to do a building method that's outside of the codes. In Germany, we call it Zustimmung im Einzelfall. In the USA, it's called alternate methods and means. So there usually always is this process where once you do the testing once, you can copy and paste it for all the other projects, right? So I mean, yes, you have to do one-time big effort, but it's not an effort that you're going to have to repeat for every project. So that's one answer. The second, there are initiatives from RILEM, from ISO, from ACI to create at least initial standards also for 3D construction printing. I very personally am not 100% convinced that it's the right time because the technology is still so bloody young and so many things will change. So I'm not 100% sure if we need a standard as of now. And then if you take a look at other construction methods, very funny to me, this is an example I know very well, the shotcrete. I mean, how long has shotcrete been around? I don't know, 50 years? Do you have an idea when it actually made it into the American concrete code?
No.
Guess.
It's not still there. I don't know. Maybe.
2019, right?
Okay. Wow.
So you have a bit of an impression there. And so hence, I think if you wait on codes to be good and work, you're going to be retired.
Okay.
So I think that's not, I think in construction, it's always been that way that the technology moves faster than the codes. And it has to be that way. So that's the second answer. And now the third, you've mentioned that you feel it's a limitation to the technology. And it can be, yes, it's an initial hurdle. On the other hand, it adds so much freedom. I'll give you a very simple example. If you have a code, concrete code, you're very limited in the terms of what types of concretes or concrete classification systems you can use. If you now try to add more recycled sand or recycled gravel, all of a sudden you're outside of the codes. That sucks. So we don't have a code. Yeah. So I have to test it anyway. Given this, why not put in some recycled tiles?
Mhm.
Why use cement at all? Why don't use something without cement? So given this, we're completely free to work outside of any framework or corset. Hence, actually, what the tiny house that I've just shown you in the presentation is actually printed with a cement-free material, right? Regarding sustainability, we're not bound by any concrete categories either. So we try to really utilize that freedom without any codes and regulations to do whatever we want, and then as long as we can prove the analogy, everybody is going to be happy, right?
Okay, yeah, I think that's a really good point. Yes, about okay, two more questions, more related to our lab, because we are thinking of like expanding our printer. We have like smaller cobot printers, like gantry printer, batch type printhead, and what I am thinking of adding right now is like trying to add is like a possibility to print together with some fiber thread when you are printing your concrete. Do you think it is a way to go? Do you see it is necessary, and or do you see it's too complicated and don't see a future for that, like printing with the same kind with reinforcement or some thread?
Oh, that's also a big question, because you probably know there's tons of research going on reinforcement integration. And I think the Theo Salé at TU Eindhoven has proven also with a lot of empirical testing very well, great work by him and his crew, that to put in a wire does help, but it's far from actually replacing the conventional rebar. So yes, it helps for cracking and shrinkage and things like these, but it doesn't replace it yet. So there I would really say, what is it that you want to do? So if you go the Theo Salé route and they combine it then with post tensioning. I've never done a post calculation on that project myself, so I don't know if it makes sense from an economic standpoint. But then technologically, that's a very viable option, of course, to do that. Yeah. Does that answer your question? Yeah.
Yeah. Well, more because we need to think about it. I know. And then the last about the materials also mentioned. Do you see a future for alternative, like for example, we are now thinking about alkali activated materials, probably those that you cure at room temperature. Do you see future for them in 3D printing?
So we've done that as well. We've actually it's not in the presentation, but we've published it just before Christmas on our social media, that we've with a geopolymer mix design made by Squape, a company from the Netherlands, that we've printed with very successfully as well. So why not? I don't see a reason why not so far. Actually, it's funny enough, from the geopolymer side, they've tried for decades to make it more fluid and longer open times to be more like conventional concrete.
Yeah.
And now we with 3D printing come along where we're like, okay, less open times and not so fluid. It's brilliant. So we actually don't have to kind of bend the geopolymer characteristics, but we can use it as is, more or less. So again, I don't see a reason why not. And again, I think also geopolymer, huge issue with codes, and we don't care. So we can just go ahead and do that, and then we can be really sustainable. We can create clever designs combined with a sustainable material, combined with autonomous construction, and then it starts getting fun.
Okay. Thank you very much for your answers. I think it's time for students. So yeah, thank you.
Maris asked all the good questions. One of the questions was about materials, so you already answered that. The other question is from Team Rebar, and the question is, there are actually two questions. One is, have you tried combining the printed structures with vegetation, like a green wall or something like that?
No, we ourselves haven't done any work in terms of basically adding flower pots into the printed wall structures as of yet. Why? It does add complexity, and I think when you say 3D printing, we tend to speak of complexity for free, right? And I think that's somehow misleading, because I would say complexity cheaper. You get it cheaper than with another building method, but if you add too many freeforms, you still pay a higher price, so to say, in terms of the fabrication process and everything. So let's try to make it more specific. The Bot2 printer runs rather quickly, but if you have curves, it has to slow down. So if you start building these curves all the way, all the time, all of a sudden your print time per layer doubles. And if you do that in a whole building, you're going to be on the site twice as long as you need be. And then all of a sudden it's not fun. Then you start creating one-off design pieces, which is nice. But let's say for a company like PERI, at least globally operating, etc., we need a certain, we can't do niches. We need a certain market size. So given this, I think it would be fun to do it for sure. And I think there's a great applications to do these types of structures. But we ourselves haven't really done it yet.
Very interesting. In that regard, I think the pots would have quite a small radius. If the form has large radius, then the slowdown is not that high, right?
Then, yes, exactly. Yeah.
Okay. The second question from students is, well, I think you already answered it in the presentation, but maybe it can be clarified. So when printing, the additional steel elements are added during the process, is it also possible to prepare them before printing, like something in that regard?
So I assume that question is I'm guessing here the question could be on the little, let's say, wall binder staples that we put in, or it can be the rebar
I guess
itself.
for those and also for the rebars, I suppose. Probably
so,
for the rebars more.
Yeah. So the rebar cages as such were mostly prepared off the site. But again, the rebar that we put in was not put in while printing, right? It was always put in at the end of the day or after we were done with a story. So it wasn't really integrated into the print. It was done before that. And all the staples, they are 100% included while we were printing. Yeah.
Okay. There are two more questions. One is about print height. So when you said that it took like 8 days to print the second story, which the limitation you think you will hit first long term? Is how much concrete can sustain layer heights before curing, or it's more the speed of the machine?
So you mean the build-up rate, basically?
Yes.
Yeah. Okay.
What's the slowing factor there?
Yeah.
Why not whole house in a day?
Yeah, it's really it's not necessarily the material. It's really more of the layer time that we need for a whole structure, and then after 6 hours, you might have a meter and a half of a whole building, but not more than that. But yes, you could speed up the process. Of course, the printer can run faster than you could do maybe a story a day, but you simply have these more than a story a day, I think would be very difficult to achieve in the overall construction process. Then you need lintels and slabs and etc. So you need to take that pause anyway. But the material could do it. I think most of the materials that we've printed with, they could definitely do 3 meters of print in the course of 6 hours. From a pure material standpoint, that would surely be feasible.
Okay, so basically, if you integrate the lintels into the design by building arches or similar elements, it could be done much quicker.
For sure, it could be done much quicker if you do that. But again, latest at the slab, you will have to stop. And then you need to be sure that you have somebody who puts in the windows to a decent price.
Yeah. So also about cutoffs, when you have the window edge, is there issues when you are cutting off the flow of the printer, or it manages it quite easily?
So there we've tried various approaches to integrate the windows. One was where we basically, so the facade, the print, and then it kind of curves inside. And then again, at the end of the day, we just took a little float board and we smoothened that, done. to make that. So because that layered structure would be very difficult to make it watertight. That's one. The other is we had the facade move in, and then we just use a trowel to cut it off, and then we pushed in the facade, the window from that end. So at least for now, and again, also according to codes and regulations, to make the window air and watertight, it really does need a smooth surface. So it doesn't even matter if we can create, if the stop and starting points are very good, they will still have this layer structure, and then we will have to do something. But to just dare a little manual work, a trowel goes a long way. Yeah.
Okay, very interesting. Thank you. The question from students is, have you tried printing organic materials like clay?
7 years ago, I think we did a couple of clay prints, but not since. I mean, clay is for structural purposes simply not feasible. You could look into printing with earth type of materials, let's say. There, permitting would be a bloody nightmare. I mean, it's difficult to get a permit with these types of materials if you do it conventionally, say alone after we printed them. So interesting to look at that. But again, kind of just here, I always have two hearts in my chest. From my academic heart tells me, let's do that. Let's go that route. It's fun to do, and that we should. And now the business mind says, okay, what's the market for earth buildings right now? Not very significant. And then my company mind says, okay, we as a company are not going to be actively pushing that. Yeah, that's the answer.
I think we need to have a guest lecturer with these code writing agencies and ask them why are they making our lives harder.
I hope that my lecture was more fun than that one.
Yeah, I think the threshold is very, very easily reachable. So definitely.
Yeah.
There is another question. I think you definitely answered that one, Daniel, about the temperatures they have printed in desert and in -5 degrees, and that was lowest how low they went. So the question was, can it go to -25, for example? But the part of the question that you might answer, and probably not yet maybe, but how long do you see, how long term do you calculate the lifespan of the building? Can it last 20, 50 years?
I mean, the short answer is I don't have a bloody clue. Is for the honest short answer. I think the first 3D printed house in Europe was printed in 2017, right, in Denmark. So I mean, there simply isn't a house that actually has been around for that long. So until that point in time, I think we will not know for sure. But we tried our very best to in the lab to put the printed structures through a lot of stress to try to test them for the longevity with the so-called freezing and thawing testing, salt attacks. So to try to highlight that. Given this, as those tests performed actually above our expectations, we feel that these structures will be very safe and sound also in 25 years. 100% sure we need to meet again in 20 years, and then we can take a look. Yeah.
There is another question. I will try to specify it. So basically, you mentioned that you have printed in several countries. What are the common issues when you try, like which issues come up the most when trying to implement
3D printing
locally? Yeah. Like.
This is a issue that's not specific to 3D printing. It's actually specific for any innovation in the construction industry, from my point of view, and that is the fragmentation of our industry. I mean, if you do, as mentioned, and very initially, I've worked for Daimler in the past, and there, if you do an innovation and you make it into Daimler, right, with that little invention you've made, you're done financially and impact wise. You're done, right? So, or perfect. Let's say I'm gonna take the 10 biggest contractors in Europe, and I'm gonna add all of their market share together. Then I'm gonna be ending up with 0.1 zero something, probably maybe 0.1, but it's going to be tiny. So the average contractor in Germany has 4 employees. The average contractor in the USA has 8, right?
Wow.
So just it's crazy. So hence you have to convince so many people. And if you just take a look at the individual project, you're gonna have an electrical and building physics and structural and roof and window and tiles and plastering, and all these people you have to convince and get them on board. And there it's maybe a funny story here. When in one of our buildings, again, right, we said, look, nobody has to cut any slots, and what normal your electrician does that, but nobody has to do it. So we asked for offers for the electrical installations, and we thought, okay, they should obviously be cheaper, right? Because there's less work. All of them were 20% more than conventional. Like, what's going on here? And everybody said, well, I've never done it in a 3D printed building, so I'm just gonna charge more to be on the safe side. And these are the hurdles. Again, not very 3D printing specific, but very broad problem. But it's a big one. So we're gonna have to be patient to share knowledge and share learnings with all these people across the globe, and then take it step by step. Now that I've painted a kind of this dark picture, I want to make it a little bit more positive, though, in terms of if you. I mean, the industry is just bloody huge. I don't know the numbers from Latvia, but let's say in Germany we build roughly 100,000 single-family homes a year. One country, one building segment. It's actually a little less, but 100,000 is a nice even number that I can actually calculate at this type of time of the day. Let's say I want to have what is a significant market share? I don't know. 3%, right? Huge, obviously. So, and then how many printers would I need as an installed base to do that? We say roughly 300. So if you know, it's gonna be already billions in money and hundreds of houses that people live in that have been built more sustainably and faster. And so given this, yes, it will take time. But as the industry is so bloody huge, also in relative terms, small market shares or whatever, will still have a huge positive impact on our world. And so I think we will always, that's at least the way that I like to look at it, to not end this on answer this question on a negative note.
Very good. I think we have time for 3 more questions. One is from Erwin, so we will read. One is from Juris, which we will start with, and then we have one more if someone adds something there. So let's start with Juris.
Oh, hi, Fabian. I'm from Plastic World. I wonder how PERI was started with concrete printing, because your main business is scaffolds, yeah, and all about building. You have in the past some ideas how maybe it's better to print with the plastic, like permanent forms or molds that can be filled with concrete, that you have no problems with the beton, with the concrete. Things. You can fill with everything what you need, what you want, free to fill with.
Am I understanding your question that to print a formwork and then fill it with concrete?
Yes.
Yes.
You even showed an example.
Yeah, that's okay. Then I got the question, and it's here on my screen. It's a tiny picture, so understand that.
Here is concrete.
Yeah. Okay. Got it.
Then,
so if you do it with little building blocks, it's gonna work. But I mean, there is a reason that formwork today is made out of steel very often, or steel and wood combination. Why? Because you have a lot of formwork pressure. So you can easily have 60, maybe 100 kilonewtons of pressure at the bottom of your formwork. And we've actually tested 3D printed out of as well nylon, carbon reinforced, whatever, polymers as well. And it simply won't hold for larger structures. So it's the concrete pressure is tremendous, and then they will break and give you a huge mess. So if you do it on a smaller scale, sure, that works. And if you do it in building blocks, that works as well. But then we come back to the question of, well, do I want to build in modular construction, or do I want to build it in situ in one go? And this question, again, to me, doesn't have anything to do with 3D printing. That discussion has been going on for decades. What if you want to do modular or not? And both have upsides and downsides, and they're completely independent of if you print them or not. Yeah. I hope that answers the question. Yeah.
Yes, you're satisfied with the answer. So the next one from the students is, how do you restart printing after the previous layer has already cured? Like if you leave overnight and restart printing the next day or week, how do you stick back? Oh yeah, so how do you join together cured and freshly printed layers when you continue?
Yeah, so we call this the cold joint that you always have, and the easy solution here is really to use an adhesion agent, usually off-the-shelf construction products. You use them in all sorts of other construction applications. You put on one layer of an adhesion agent, then you print on top of that, and then you're golden. There's epoxy-based, mineral-based, 2-component, 1-component. There's various adhesion agents that can do the trick. That's very dependent on what exactly the composition of your material is. Is it hydrophobic or not, etc. So, but yeah, adhesion agent is here the answer in short.
Okay, thank you. And the last question for the question section. So you mentioned that you painted the facades. What are the common ways how you protect it from being exposed to the elements? Maybe some hydrophilic coatings, hydrophobic, sorry, and etc.
Yeah. So the hydrophobic coating can be so a coating can make sense. We actually advise to not put the hydrophobic agent into the material itself. That can lead to quite significant problems. Hence, but a coating can make sense, but it doesn't necessarily have to be. That again depends very much on what type of material you have at hand, and how the material itself is being made up. Again, we've been printing with so many different materials that this one doesn't have a generic answer. I'd say if you want to be on the safe side, you probably do it. But if you want to be efficient, then you would have to take a closer look at what type of material you have at hand.
Okay. Perfect. Thank you for being so open with all the information here. And I think we can move forward with student ideas. We don't have that much time. I think we will not do individual presentations. Maybe you can give your quick input, and then if students have something to add, they can. I will share the screen and just, I hope I shared the screen where you actually can see it. Very good. And I will zoom forward and go through. And if you want me to go up and down, you can definitely inform that some students updated their posters a little bit for you. And otherwise, yeah, roughly if you go 5 minutes for each team, not more than 5, then we should finish in time.
Understood. So here, I mean, it's just to be doubly safe. This is the idea is here to print it in prefab elements and then bring those to site, correct?
Yes, actually, it's for all the themes. Our current printer dimensions are limited.
Perfect. Good. Yeah. Then just to be doubly safe that I'm not saying anything wrong here. To me, I like the design. The overhangs that I see could be potentially challenging depending on the print direction. And to me, what would be the biggest challenge is definitely how are you going to be dealing with slump in the material. I believe it's very difficult to print with, I guess maybe a size of one module could have the height of a 1.20 m, I'm guessing here. And then it has a curve and then it slumps slightly. The next piece is going to be really difficult to design to fit onto this one. If it's a straight wall and it slumps slightly, well, then you just make it a little longer and you're good. But if you have a free form and that slumps, that's going to be a lot more difficult to handle. So either you're very sure you don't have any slump in your material, or you're going to have to be printing, measuring, adjust designs, print again, measure, adjust designs. I hope I'm making sense.
It's a very good comment, because we are right now, the next meeting is on actually starting, because now each team printed tests in plastic in scale 1 to 10, and the next section is choosing the teams where we need to test some of the elements in concrete. So this is a very good comment for us to know that we probably need to test for such things too, the slump. Yeah, probably Mars already had taken a note on that, but
Yeah.
it's good to be reinforced there.
So basically just checking if you have a 1.20 m, do you actually have it? Or is it just a 1.15 m?
Yeah, that's double checking there. And if the team has any comments, you can raise your hand and I will give it. It looks like currently there is not, then it's good because we don't have that much time. Let's go to the next team, and this is their work is here. I'll zoom in a bit.
Good. Yes, that's I like this one. I have a big backyard. If you're done printing it, ship it my way.
I think you could print it in one go. You don't need to divide
They
it.
can send the files in.
And then I need to print it myself. I can do that as well. So here I think, I mean, these pieces, if that left-hand side piece is printed in one go, have you considered how you're going to be moving that one? Just of the weight perspective? Has somebody ever done a calculation of how heavy it is?
That's this step right now. No,
it's not printed in one go. Oh, it's not printed in one go.
Oh, no, okay, yeah.
Okay.
Somebody else was saying something?
No, I just wanted to say that it will be split in multiple parts, not in one go.
Yeah, but just the left-hand side of it, just this piece, that seems to be one go.
No.
Huh?
It
they
will
updated
be...
the design apparently.
Yeah, okay, good, got it. Then I'm fine. Because we every now and then play this little game where we show people a piece of printed concrete, and then we ask them how heavy they think it is. Mostly people give us a number that's maybe a third of the weight that it actually is. So these people tend to underestimate how bloody heavy concrete is. And then it can get really difficult to maneuver. So these pieces, how do you maneuver them? How are you gonna move them on with a forklift or a crane? How are you gonna putting in anchor bolts or something like that? Just consider that. It can be a very, very simple solution to put in these little threads that have a little piece of rebar sticking out of them, and you basically push them in and you should be good. But consider that. How are you going to move it? How are you going to turn it? That can be really challenging in this one. Yeah.
It's a very good comment for all of the teams, I think. Yes, universal. Do we switch to next ones, or is there anything here more?
No, we can move on from my point of view.
Yeah, perfect. This is the next team.
Good. This one, when I first saw it, had me slightly worried. There, I think it might make great sense to if you have had a thread already to print into this. So I don't think if snow loads would go into this structurally, I'd be extremely worried. Also, if it's an arch, still extremely worried on this one. So yeah, without rebar, I don't see how that could work, even if it's an arch. Yeah.
Okay, Mars had similar worries, and I think that it's not the new. I think in the newest version they made one of the arches smaller and the second one, but they will try to attempt to do it. So it will be a good challenge, I think. Yeah. So the next one is this. It's a hand, and here's the part.
The part, yeah. Okay. also here I was just wondering how to maneuver the pieces and flip them potentially, right? If I'm getting it right. Now you want to print them standing and then just move them around like that. Okay, that could do the trick, and then stack them up and then probably just glue them together. That's fine. I mean, the overhang is also fine if you print it the other way around. So spontaneously, probably the same as I mentioned earlier regarding slump, to make sure that the pieces fit together as nicely as they do in the rendering. But apart from that, that seems very printable.
So for slump, you just compensate by raising, basically scaling model in one of the axes, right?
Not if it's curved in both directions, then you can't just scale it.
Then you can't.
That's
Yeah.
exactly the issue. If it's a straight wall, easy. If it's curved in only one direction, also easy. If it's curved
Yeah.
in two directions, then it's not going to work anymore.
Almost
then you
impossible.
can't scale it. Then you're
guess
gonna.
You can offset it, but it's really tricky, right? Yeah.
Yeah. Also not quite. So you're gonna have to remodel it.
Yeah.
Every
yeah,
time, and
yeah.
that's
It's remodeling.
yeah, it's going to be
Okay.
really difficult to make. So you really have to measure, and then you have a free form. So how are you going to measure that? I hope you have a good laser scanner. And then you have to make sense of that data, and then you have to remodel it. So that can be challenging. Or you find a way to use that to your advantage, maybe have a little bit of a gap in between the elements to have, I don't know, but the slump.
I think this is a really great place where to apply machine learning or something like that. When you just calculate for specific material types and integrate it into dynamic modeling and stress is, yeah, I think the field could develop a lot here.
Yes, because I personally believe, I mean, there's people that want to make the process 100% precise.
Yes.
And I think there is no such process. Also in the automotive industry, there is no such process.
There's always tolerances, right?
Yes, and you will have to, and slump is basically the tolerance that we have in 3D construction printing. Yeah.
Well, could be the name of the lecture next time. Slump and how to deal with it in 3D concrete printing. Okay, this one it will also probably be dealing with slump.
Yeah,
although maybe not.
Maybe not so much. Can you go down here on this one a little bit? Yeah, because here, yeah, okay. So this is the idea to print
Assemble
it in
thing.
sections and then stack them.
Yeah, there's actually sections. I think one section has like few holes.
And then to basically stack them up like that. Okay. From a printability standpoint, definitely quite doable. I think here in this design, slump wouldn't play that much of a role, and I think the precision in X and Y is achievable. Still, you would have to consider, if you stack them, that you don't load the. I mean, if you have just one layer that's slightly bigger than all the others, and you stack them, all of a sudden, all of the weight will be on this one little point, and then it will start breaking, and then you will have kind of this. This will continue through your whole section. So I would advise to put some sort of foam or something between those little bricks to ensure that the loads are spread a little bit more equally across, and you don't have the single point of loading. I hope I'm making sense again.
I'm writing it down actually. Great.
Yes, Krish is saying thank you. He already noted that.
Okay,
Perfect.
very good. Perfect. So the next theme is this one.
Can you also scroll down again?
Yeah. For this one, we were really worrying about surface treatments. So some of the ideas you presented today, I think, will really do well with being incorporated.
Why did you worry about surface treatment in this one?
I think we were worried that, like, when you sit on it, as it's meant to be a chair, it will have like this feeling on your bottom that you are being.
Yeah, also some dirt might get in.
Yeah, and the dirt accumulation, right?
So there I might actually have to steal your screen again, if I may.
Yeah, no problem. I will stop sharing. Yeah.
Give me a second here. Where is it? There we go. Then I can share the screen and okay, so you can see this picture here, right? I hope with this kind of almost looks like a plastered surface. And this is done with, I believe the English term is a sponge float. So it's basically a wooden board with a sponge surface on it. And so just play around with that when you do a concrete test print. While you need to kind of fit your timing here. It can't be too fluid, but not too fast, too set already. But maybe I don't know what type of material you'll be using. Let's say roughly an hour. And then use a little float board, and you can actually use just a bloody sponge if it mightn't. I mean, a professional can do this a lot better than when we did it. You're not professional plasterers, but then you can do that and create this type of surface, which you don't. It's not plastered. It's really just a float board and done. I could suggest play around with that a little bit.
Perfect.
Yeah.
It's great. Yeah. Actually, very good recommendation. I think it's also cheaper and easier than trying to plaster everything over when it's finished, right?
Exactly. Yeah, and then you have this almost smooth surface that will be comfortable to sit on and not get all that dirty. Yeah.
Okay, perfect. So the next team. Oh, we have two teams left. So this one.
Can you share the screen again?
Oh, I'm not sure. I'm just watching it myself. Here we go. I think there's some loading happening in the background, but I will just scroll down to the pictures that have loaded already. I think it also gives a better illustration on the idea.
So there, I mean, in concrete, you will not have these sharp edges. I assume. I don't know which nozzle width you guys are using, but
currently
it's
it's 1 millimeter nozzle, which would be 1 centimeter nozzle in real life. This is 1 to 10 scale.
Yeah. So, but then it's just to be aware that these edges are not going to be as sharp. You're going to always have these round curves at the edge, right? So they're going to look a lot more rounded.
I think we can see it here, right?
Yeah,
in this place it gets a little bit, there's like this
but let's say this intersection of these three pieces, there's going to be a hole. Just to no, not actually that one, that little bit on
this one here, right? Here's the hole.
No, if you this one, yes, there it is. There you're going to basically have a hole in between the three pieces where the three pieces meet. You just have to be aware of that. I mean, if this is also going to be a bench, then it's not going to take you long until there's a lot of dirt or whatever, leaves or something is in there.
It's a very good point. So also water will accumulate there.
Definitely water, and then if that freezes, that's gonna give you big trouble.
Problem. Yeah. Okay, this is a very good comment. Well, last but not least, then we have this team. So their idea is to print each of these elements separately and then combine them. I think there are like 4 different types of segments in the total.
Yeah. Okay, understood. Very similar to the comment previously, right? You're gonna have the same if you're printing them upside down and then you're turning them on the side by 90 degrees, you're gonna have the load on the layer structure, which we definitely would advise against. So again, put something in between to better convey your loads more across the whole surface. Printable, I don't see an issue. Overhang, I mean, again, if I yes, also not a big deal here, I think. Yeah, that's all good from my point of view. Yeah, well, no big issues with this one.
Yeah, we went through quite rapidly. I think if anyone has some closing questions or statements, then we can definitely go through with that. There is one written question. I don't specifically know in what regard it was meant, as it came a little bit ago, but it's savings in % achieved in the United States in material labor or overall times. Like, was it cheaper to do it in the States? And then Maris will have a question after that.
So that's always a question. So the States is a big country. So this is a, so for Germany the answer would be difficult, and for the US it's even more so. But in short, no. the US, from a construction standpoint, in single-family housing is a third world country. Any Americans on the call? I'm sorry.
Maybe one or two.
One or two. Sorry about that.
Very understanding one.
Yeah. So it's hence, I mean, the labor is potentially actually cheap. You have timber frame construction, so those are thrown together, and then the next hurricane blows them away. So if you compare it to this type of structure, 3D printing is not cheaper, but you have a very different value proposition. So in Central Europe, or I think in Europe in general, it's really difficult to say, look, we're going to build you a house of higher quality. With European building codes, the quality is always pretty high. So there you need to be happy if you can say, look, I can meet that quality.
I can build cheaper, is very surprising.
Yes, but in the United States, it's more about, look, this thing is not going to burn, it's not going to rot, it's not going to be blown away by your next hurricane, it's going to be lasting longer. You can get cheaper building insurance, which is a huge deal in the United States. So it's a completely different approach, a completely different business model actually, that you have to follow. Cheaper, at least for now, no, that's it's not.
Yeah, there's a lot of thank yous in the chat for you. Also, the students were very happy about the recommendations. Yeah, Mari, we are ready for your question.
Yeah, thank you on the comments on the students' work. As you saw, a lot of them are like different, like small elements joined together. How do you think? What do you see the best way to joining them? Because some of them are thinking about some screw elements to be printed inside. Some of them are thinking some gluing together, epoxy, maybe to mortar them. Some teams are thinking this like a rubber thing that you put between precasted wall panels, like it's black usually. What do you think is the best way to join such like a small elements together?
So what I've seen now I think I have to split up the question slightly, because some of the projects that I've seen were basically printing bricks, to call it like that's at least kind of my perception. And if you are looking at the same kind of structural approach to a brick, then I don't really see why mortar wouldn't do the trick. And so that's fine. But if you look at structures that are supposed to be more akin to concrete, then I think a combination of a epoxy and some sort of a screw solution would be the way to go. But then I would combine the two actually, not epoxy only. Yes, I hope that answers the question. Yeah.
Yes, that was a good answer. I think we have gone through a lot of questions and a lot of answers. We can allow anyone if there's anything else to add, but otherwise, I think thank you for joining so late, and then it was very, very valuable. I hope we will be able to sometimes meet all again, or maybe when we finish the project, we can share the results, how it went, and who knows, maybe PERI will be interested in doing a competition next or some other year, as some of the students' ideas are quite big for our local printers. So if you ever decide to bring the printer to Baltics, you know where you can get some designs already to do challenging test prints. Yes.
We like challenges, as I hope came across. So thank you for that, and I would love to be updated on the results, of course. So definitely some great designs, great ideas. Would be really happy to see how they turn out.
Perfect. We'll definitely send some emails for you then. Yeah, sure. Okay, well then, thank you, and thanks to all who joined, and then I'll see you all next week.
Perfect.
Goodbye.
Thank you all. Bye.
Perfect.